In example 4, we have a few different parts. Part A here says if B and C trisect segment AD, and so trisect is a special word that means cut into 3 congruent pieces. Then we're going to find the coordinates of B and C, and we'll find the length of AC here. So let's work on the first one together. We have -5 and 16 here given as A and D, and this appears like it's like a kind of a number line. Trisect means that this piece is congruent to this piece, which is congruent to this piece. You can guess and check here, and I'll show you a mathematical way to do this here in a second. If you guess and check, you might choose 5. So this would be 0, that would be 5, and that would make this 10. So that's not enough. You could pick maybe 6. So -5 and 6 is 1, 1 and 6 is 7, 7 and 6 is 13, and get closer. And you might think that the next one would be 7, and you would be right. If you look at the difference between -5 and 16 though, that's 21. We have 1, 2, 3 pieces, so 21 divided by 3 is 7, making each segment worth 7, so that's perhaps a little bit quicker way of doing it. -5 plus 7 is 2, and then 2 plus 7 is 9, 9 plus 7 is 16. So each one of these segments here is, or has a length of 7. So B and C, we'll do B is 2, and C is 9. That'd be enough for this one. I want to find the length of segment AC, so that's from here to here. Notice AB is 7, BC is 7. If we add 7 and 7, we get 14. So AC is 14. There's another part to this example. Actually, we've got a few here, I think B and also C. So we'll take a look at those. We're given here that B and C are trisection points of segment AD. So B and C are trisection points, AD. The measure of AD is 12. So from here to here is 12. 12 divided by 3 is 4, making each one of these segments worth 4. Let's find the measure of AB, which is denoted by just AB. So AB here is 4. We got it. AC would be 4 and 4, or 8. Now we're wondering if AB is x plus 3, we'll solve for x. So we know AB is also 4. So we'll set x plus 3 equal to 4 and subtract 3. And x would be 1. You can circle your answers here if you wanted to. For the next one, we're wondering if AB is x and AE is 3x plus 6. So this entire length here is 3x plus 6. We want to find AE. Well, if AB is x, then x must be 4. So AE has to be 3 times 4 plus 6, which is 12 plus 6, or 18. What segment is C the midpoint of? So C would split segment BD into 2 congruent pieces. So we'll list segment BD as C is the midpoint of that line segment. We have part C here. So we're given in this one, and these are kind of a little small to read here. Hopefully you have the notes there at home. Given the measure of angle ABC is 90, so ABC is a right angle. Measure of angle 1 is 2x plus 10. I'll try to write that a little bigger so you can see it. The measure of angle 2 is x plus 20. So we've got x plus 20 here. And the measure of angle 3 is 3x. Has angle ABC been trisected? So we're wondering, this is the question here. We're wondering, is the measure of angle 1 the same as 2 and the same as 3? If it is, then that angle's been trisected. If we take all 3 of these angles and add them up, we'll get the whole angle, which is a right angle. So we can do 2x plus 10 plus x plus 20 plus 3x is equal to 90. Combining like terms, 2x, x, and 3x is 6x. 10 and 20 is 30. We'll subtract 30 here. 6x is equal to 60. Divide by 6, and we find x to be 10. If we substitute 10 in here, then we have 2 times 10, which is 20 plus 10, making the measure of angle 1, 30. 10 plus 20 is also 30 for the measure of angle 2. And 3 times 10 is also 30. So the answer is yes. It has been trisected.